Is there sound now? Let's hope there's sound. It looks like there's some kind of sound. Okay, hello, welcome. This might be a bit of a shit show, but we'll give it a go. So I've switched to Linux for reasons, and it's my first attempt to stream from Linux using OBS for many years. One of the reasons I switched to Windows is because streaming from Linux was a bit clunky, and also I haven't set everything up properly, so it might be a little bit of an issue today, but we'll give it a go, see what happens. If anyone's watching live and you notice something wrong, can you let me know in the chat? I'll try and fix it as we go. But otherwise, I'll assume that there's some kind of picture and some kind of audio. I don't know which audio, but it seems to be capturing something. Okay, so plan for today is to have a look at Advent of Code Day 12, because that's what day it is. Which I haven't really looked at yet. I've just opened the browser. I really meant to read it before and I didn't get around to it, but let's give it a go. It's audio. Okay, audio again. That's not clipping too much. Seems to be a little bit. Okay, clipping a lot. Let me pull this down a little bit. Hopefully it'll stop clipping. I'm going to pull down a little bit more. There we go. Hey Tim, can you confirm you can hear this okay and see the screen properly? Because it's being a bit of an issue. I'll find out. Okay, so looking at the challenge written that, the bit I've read so far is you have the garden for a layout, and you have plots inside here, and it's things with the same letters that are touching. And you need to work out what it was terrible. But it might not be your fault, I think this might be my fault. I don't know what terrible means as well. Hang on. It's not like a web coder, oh dear. If I switch to that, does that make it any better? I don't know. It worked earlier, and then when I started streaming, it lost the audio device because it's Linux. So I'm trying to find out which one it was set to and it's going to work. Does it still sound as terrible? Sounds good. Okay, cool. You're in a different browser, Tim, but also I changed the audio device. So it's some combination of the two. Audio is super choppy. Oh no. I should never switch back to Linux. This is a mistake. I should just stream from Windows. Okay, with some choppy audio. Better now. It's really weird. I wonder what happened. I wonder why reconnecting helps. It's very strange. Okay, so yes, I need to work out the length of a fence. I need to know an area and a perimeter. So the area is the number of garden plots the region contains. So here the area is 4 because there's 4 of these, and there's 4 Bs arranged in that grid, and 4 Cs because they're touching 3 E's and 1 D, I guess. Yeah, that's what it says here. Okay. Each garden plot is a square, so it's 4 sides. Perimeter region is the number of sides of garden plots and regions that do not touch another garden plot in the same region. A and C are both with a perimeter of 10. So I guess that's 4 across the top, 4 across the bottom on each side. Stop flipping away. Okay. B and E are perimeter of 8. So that's 2 down, 2 across, and 2 back up. But C is Okay, I guess you work out the whole square and then subtract the things that are touching. That's my way to do it. So presumably D is 4, and E is 8 as well. What was C? Whatever that is. C has got 10, A has got 10. Oh yes, because it's 2 4s and then 2 sides. Okay, plants of the same type can appear in multiple separate regions, and regions can appear within other regions. Well, this is complicated. So it contains 5 regions, 1 containing all of the zeros, and 4 containing a single X. Okay, the X's have a perimeter 1. Sorry, area 1, perimeter 4. The region is 21. No, the region containing the 21 type of plants is more complicated. So it's got an outer edge and then the boundaries. Okay. And then we need to multiply the area by the perimeter to get the price. This is going to be a little bit tricky. Okay, so A has got that price, whatever, and then you add them together to get the total price. Okay. I'm going to start by calculating this one. I think this is, I'm not convinced I'm going to get this done today, but let's start and see how far we get. Okay, so I'm learning nix. Isn't that exciting? So I can say nix init, nix flag init, and I've got a template called John Haskell. There we go. Okay, and then I should go say nix develop. Don't need to command fish because it should just do that. I'm learning nix. I'm also learning helix. So I don't know why I changed everything. I think I just get bored, but everything's going to be a little bit more interesting today. Okay, so I'm going to move example cabal to AOC 2024.cabal, and that should be enough. Look at that. So I'm going to rename this to AOC 2024. That should be the same, but executable. I will rename to AOC 2024 app. Save that. Just quick second and see if cabal run works. No, unknown package example. Because I am build depends example, and it should really depend on AOC 2024. Just go to another window and say nix develop, name cabal run. Now I write the app. That's what I wanted to see. Okay, so in main, that's all we have so far. Okay, so I can say something like sample equals, and then it was that string. Oops. Say star. Look at that. Okay, so that's the sample that we were given. And I want to identify regions in it. I guess you start at the beginning and just, even identifying regions is tricky in itself before you get to the perimeters and all that kind of stuff. So what's this going to do? We'll take a list of, we'll take a string, turn a string, string. Is this working? No language server, no configured language server supports that. Why is the language server not working? Haskell language server wrapper. Does this load? There was something I didn't like the look of up here. And that's okay. This stack is not found. It's found GHC, it's found Cabal. Find a hole. Should be okay. So I should be able to say LSP restart, hopefully. There we go. It's found a hole. Good. Okay. So this I can say at signature and then solve is underscore. And here I can say interact solve. Right. So what do we do here? We want to turn it into I guess we just read through the string, couldn't we? Remember where we are. I was going to say I could turn it into an array, but it kind of is an array. It's already an array of arrays if I just call lines on it. So if I start at the corner and walk as far as I can to the end of the line until it stops matching that letter. And then when I've stopped, I'll go to that position, that start position, the next line, and try and read that as a touching area. I presume touching means not diagonally. I'm going to assume that. Let's find out. So what I'm thinking is if you start, imagine you have a grid which is A, and then B, B, C, D, and B, B, C, C, and E, 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 C. I'm going to start at this position. I'm just going to keep walking this way until I run out of line or run out of that letter. But I need to remember my start position was here. Then I'm going to go to the next line and see if it matches A, and if it doesn't, oh no, but you could go down from places that aren't there. So I guess I need to walk all the way along here until I get to the end of where this thing was. See, that's not even true, because you can also have, I guess you could have something like BA, and then this could be something like that. So you could walk down and then back up again. So that's no good. Just wondering how I'm going to identify regions. I mean, do you start from here and see how far you can reach? Is this another bloody Dijkstra problem? Or like a graph problem? So starting here, something's reachable if you can get to it horizontally or any combination of directions. I hate these problems. Do I pull out positions of all the A's? So if I turn this into a bunch of A's and nothings, or A's and spaces, then how do you know they're connected? Again, you're going to have to say what, if I'm in this position, travel all directions. And if I can, and from here, travel all directions, but don't go back. And something from here, and remember which way you found a connection. Okay, so if I said something like, oh, hang on one second, does this work? Can I evaluate that? I cannot. Okay, so I've got no quick inline thing. Horizontal split? Nope. Vertical split. That's not even what I want, actually. I probably want this. There we go. So I can go to here, next develop, and I can run them side by side. Okay. So I want to say, given some grid, starting from some position and some letter, find everything it's connected to. So I'll start with just the letter A. So I'm going to look for a character in a string, and I'm going to return. I don't want to return even. I like to work out the area as one thing, but I really want to work out. Let me return the area. I'll just make that int for now. Find connected. So find connected, given some character and some input. Oh, this should probably be a list of strings because we're going to break it into multiple lines. Okay, this will work recursively. So will it work recursively? No, it might not actually. So what I'm going to do, I'm going to need to know the start position. So the start position, I guess, is going to be 0, 0. And list of visited, let's say empty, something like that. So go is going to have the start position, which is the current position, I guess, which is list of ints. The visited, which is list of ints. The character we're looking at and the string. We don't need the character we're looking at because that's captured in the outside. And the grid I'm probably not going to modify. So let's just try that. So go, what's go equal to here? So given some x and y and an empty list, no, let's say visited. Okay, what do I want to do now? I want to work out for now, I'm just going to say let's touching. Get touching. I'm going to work out all the touching nodes. Okay, let's try writing just that. What's it say about here? Oh, it's not an area. It needs to return an int. Let me return 10. For no reason. Okay. So touching. Given some character and a position. So I've got a position. Actually, I'm going to put the character first because that will never change. Given a character and a grid. Grid is a list of strings. And a position. I want to return an array of positions. It's going to alias that. So position is a pair of ints, and the grid for now is just going to be a list of strings. So aliasing isn't doing much for me, but I'm using it to just make these types of things a bit smaller and also a little bit more descriptive. These should really be new types, but actually pause should probably be a data type with 2 values, but I'm not going to do that. I'm just going to keep it simple for now. Okay. So this is a grid. And this is a position. I'm going to be back a list of positions. Okay. So touching. I'm just going to get rid of this for a second because I'm not using it. Touching. We're going to say what are we going to say here? So we've got a character, we've got a grid, we've got a position which is an x and a y, and we're going to return all the positions around there which are not which contain the same character. Okay. So let up, we're going to say if y is equal to 0, then nothing, else just, oh, it's going to be horribly nested. Yeah, it's horrible, right? So we're going to say if y is 0, then we can't go up anywhere from it. So it's going to return nothing. But if it is greater than 0, then it's going to be then we have to check it, right? So else if right, helper for getting stuff back. We can say just x y minus 1. Okay, let's work these out first, bit by bit, right? So down, if y is equal to the length of grid. We're going to start from 0. So it's going to be length of grid. Oops, not the type grid, but the actual grid. Minus 1. Then nothing. It's just x, y plus 1. And left is going to be if x is equal to 0, then nothing. Sure, there must be an easier way of doing this, but I've started, so I'll finish. And then right is going to be if x is equal to the length of anything inside the grid minus 1, then nothing else, and then it's y plus 1, sorry, x plus 1, then y. So all of that in, so we know what the coordinates are, and now we first of all want to filter this. So given some x prime and y primes, these are new coordinates. Let me write this filter out because it's a little bit long. So we're going to say check same, that'll do. So given a grid and the position within that grid, and a character that we're looking for. Given a character, a grid and position within that grid, return a Boolean, but it's not a grid anymore. And this is a maybe post. That was the thing, right? It is still a grid. So check same. We don't care what the character is, we don't care what the grid is, but if we have a nothing, then it's false. It's not touching. Check same. And if you have some character and some grid and just x and y, it's going to be grid bang y bang x equals c. So we can say check same with c and grid over up, down, left and right. Okay. So what's the problem here? Why not use head? Okay, use head, that's fine. Then it's going to complain that it's partial, but again, I'll assume the grid is non-empty. This should be just that. These are bang bangs. Okay. So now this will give us check same is given the character we're looking for and the grid. Okay, those, and then it's got, oh, sorry, listed. It's not a grid. It's not a grid. Okay, it really is not a grid. No, it is. It is a grid. I'm thinking here. What should happen is each of the elements inside this, which is maybe pos, is it? Maybe int, maybe int. They should all be fired into checksum. And that's from a bool, which will decide whether or not to keep it, right? A to bool, list of bools. No, sorry. A to bool, a list of A's. So this is maybe pos to bool, a list of maybe pos. That says a list of things. Maybes, is that a thing? So I want to go from I go from list of maybe A to a list of A, and that's called cat maybes. And I can import that. Okay. Okay, so given some grid and some touching stuff, no, sorry, given some grid and some character and an initial position, it should work out what's touching just that single position. Okay. Everything's exported now. Okay, so we can say something like so grid is equal to words of sample. A list of strings. And then what? We need the character and position, so we can pass those in. I can work those out. That should be fine. Okay, so now bring this back again. Go here. Cabal REPL. Okay, so if I just say grid, nope. Can I import main? Can I load main? Maybe. Not really, because there's an error in there. Constant. Okay. No, they're just warnings, there's no actual errors. Okay, so back here, can I load that? It did load it, okay. So where are we now? So do I have a grid? Look at that, I've got a grid. Okay, so if I say touching, I want A in the grid at position 0, 0. And it finds it touching the thing next to it. Okay, that's kind of cool. So if I say, well, it's not that cool. If I say I'm going to look at row 2, position 3, so it's this C, it should find one above and one to the right of it. X and Y, okay, so one above and one to the right, okay. And now I have a look at this one. It finds, that's not correct. So it finds one to the left of it, so it's find, so I'm starting here, it find this one, but it didn't find this one. So I'm in row 3, and the length of the grid minus 1 is 3. Which is not what I want. I don't want to say no, wait, sorry, that is the right answer. It was 3, 2. Sorry, I started here and went up. I didn't mean to start there, I meant to start at 2, 3. And go back, and it can go down. Okay, that's cool. And 2, 2 can go up and right. No? Yes, up and right. Cool. Don't need to pass C in, because in theory it could get it. It knows the position, so it can say, at this position, find everything that's attached. We don't really care what the character is. So, like we do care when we're checking it, but we could say C is equal to grid at Y at X. So go back here and reload it. And then I can say touching grid there. That's good, it's giving me some answers. And then 0, 0. Okay, right, so for a single point, I can find out what's touching it. So what we now want to do is say, follow those until you can't reach anything else, but don't backtrack. Okay, so given some position and a list of visited stuff, what are we going to do at this point? So we want to get back all the touching. We want to filter out the stuff that's in visited. This is going to get very slow, I guess, but it might be fast enough. Let's find out. So we can say let touching. That's going to positions. Can I say poses? This is horrible. Poses. Poses is equal to filter not elem visited of touching. Let's see, it wants grid. Have we got a position here? Yes, we got a position here. Maybe we don't need this destructured, so we just say position and visited. Okay, how is this not going to work? So, no, import data.list, I think. So can we say something like is 0, 0. Oh, no. Is that an element of a list containing, what do we put in the list? We'll put 1, 1. That should be false. Doesn't know what the types are. If I say 0 and 0, it says true. Okay, that's what you expect. So what I really want to say is can I say not elem 0, 0 in there? I cannot, no. Can I say that? Yes, okay. And then can I say, so that's false. So filter not elem that, so that's the visited list. Let's do a couple of things actually. So we can say 0, 0 and 1, 1. And we'll have an attached list or next list as 0, 0, 0, 1, and 1, 0. No, that's not quite how it works. Okay, if I say that does work. Okay, let me write that out and then see if the compiler can fix it. Is there some kind of temporarily maximize in Kitty? Don't know, because that overlay is very annoying. Do that for a second, just so I can say, oh, I can import that. So filter, give them some X. I'm going to say not elem_x visited. There's a not elem, even better. So now I can drop the lambda. Okay, getting closer, and then couldn't match pos to string with actual type. List of pos. Function touching is applied to 3 arguments. Ooh, yeah, it shouldn't be. I don't need to see anymore. Okay, now what we got. This gives back a list of poses, and this is a grid, but it's not a grid. So visited is not a grid, it's a list of pos. Okay, so now what it's going to do is going to be back the area, but before, well, the area is just a count of those things, isn't it, right? So I can just say length of poses. So let me try that. Loads it. Okay, so I say find connected. Do they use seeing grid? I don't know. Let's find out anyway. I'm going to say A, using the grid, and it starts at 0, 0 and returns 1. Of course it returns 1 because it's not what I wanted to do. That's not what this is supposed to do. Don't return an area, return a list of poses. Okay, this is not going to return an int. We're not going to return an area. We're going to do 2 things actually. We're going to Oh, that's okay. I think. So we're just going to recurse. What are we going to do here? So what we actually want to do is for everything in those new positions, we want to call go again. Oh, this gets tricky again because I need to update the list as we go. So we can say let me try a tuple here. We're going to return two things. We are going to return no. I was going to say I'm going to return all the connected things and a new visitor list, but that's not quite what I want to do. What can we do? So we can go, we can map given some new position. We're going to go to that position. I'm going to pass in the position we're at on the list of visited. So this is going to find, it won't in this grid, I don't think, but this is going to find duplicates, which is not what I want. But we can maybe, if this works and finds duplicates, we can fix that. So we're going to go to, what's this? The type of this is a list of positions. Okay, so this is a position. I'm going to say go to a single position. And then the second argument is the current position it's a single position, right? And then this, no, it doesn't know what it is. That's a position, and this is list positions. Let me just work this out because I'm not quite sure why that didn't work. Okay, so the type of this is list of positions. Okay, so I should say go position list of positions. Oh, I see. Hang on. Okay, let me apply that hint. Is it like concat map? Okay, because that would be a list of things. Sorry, I've just seen the comments. I need flip, like flip elem. Yep. So that was the hint it suggested with the backticks for the inline. Touching doesn't have C anymore. Touching doesn't need C, I don't think. Yep. Visit is empty list. I don't know what the visit equals empty list means because I missed the context of that. Sorry, because I've just seen it. Okay. Ooh. Loaded. Let me find connected and A in the grid. Find nothing. That's not what I wanted. Okay. to extend roommates for that context. I wish people could actually just pair on this and reach in and help, because these are quite tricky to solve. One of these makes it go away. Oh, that's probably what I wanted. Okay, cool. I can flip between them a bit more easily now. Side by side. Okay, so I don't need this anymore. It shows an existing binding. Okay, so I can call this. They all show that binding. Okay. I should recall this something like sample grid. Okay. So let me not do that. Let me just give me back the pulses, make sure that bit is okay. Because I called it sample grid. No. Oh, I've dropped the AI. I didn't need it anymore. Okay, it finds the next one. So that part is fine. So I just change this to be map. I'll just do that. And then this is ms that, no, ma that, ms that. There we go. I can't do that. I need to flatten it as I go. But this didn't work. So for each of these, I want to go again. Do I need to flip in there actually? Let me just check. I don't think I do. So given some p, I want to go to there. Yeah, it says that's the same thing. Okay, I haven't made any progress. I'm an hour into this. Oh, I need to remember the pauses as well. So I was constantly recursing and finding new things, but I was throwing away the ones I'd found. I think that's what's happening. Okay, so that's kind of good. We need the current position as well. So it'll be the current position, then all the new things we found. So you can actually, I could do this as position. Okay. So those are all the things in the first row. Then I need to find the next thing that's not in that list, the next position that's not already counted. Okay, and how do we do that? How do we do that? So what I then need to do I'm just wondering a couple of things. So one is I kind of want to keep hold of this visited list because I never want to revisit anything. There's no point in going somewhere if I've already been there. So I could hand back the updated visited list, but then how do we find the next thing? Remove the ones you find from grid. Remove the ones I find from grid. So you turn like a list of lists. Okay, so to remove the ones I found in the grid, I need to know where they are though. I can't just remove them, I don't think. So we have something like this. If I returned it worked for list of A's. Let's say I'm doing the C's though. If I delete them from the grid, I move everything else around, so that's not right. I can't leave a hole there and say, you can't go there. But what was wrong is if I start here and then let it run till it's finished and return all the places I've been to the updated visited list, and then I go to the next element here, so I kind of flatten it and go forward. And just skip over them because they're in the visited list and keep going till I get to something that's not in the visited list. Or I could turn them to nothings, which is kind of like skipping over it. Let me just see if I get the visited list back out again properly. So I'll return these two things. I don't think I have the correct version of visited here. My concat map doesn't work because what I really need to do is join all those visited things together. So I can say, this is horrible code. What's this going to give me back? It's going to give me back some result and like a new visited. I don't even, there's a let for this. I can say that's just equal to concat map. Go. I'm going to get rid of visited prime. I can just put toss onto start visited. Concat map that positions so let me get rid of this. In, and then what I'm going to return is P on the front of other results, and then the visited I was given. Actually, no, I'm going to keep that. Visited list generated joined to whatever visited came back. Right. Returns a tuple, is that compatible with concat map? It's going to be. Oh no, you're right. It's not going to be a list of lists anymore. It's going to be a list of tuples containing lists and something else. Yeah, it's a good point. I wish the chat was quicker because it would save me a lot of time. Okay. What else can we do? I might just call it a night. I'm not going to get very far with this. I kind of feel like I need something to collect up all the results. And I'm wondering, like, do I run it under some kind of state monad and just collect the things as we go? But it's a big rewrite. It's a lot of stuff to write now. Yeah, this was not the one to tackle in a 1-hour coding session. I should have pre-read it and picked something easier. Second of Go. Yeah, I think I see where you're going with this. So like if I get it to return the tuple, and don't use concat map, just use map, and then pull out all the seconds, and then concatenate them together. I think that might work. I don't know. It does feel like I'm actually manipulating state, right? Because as it goes, we're just adding to this state of the visited list. So the proper way to do that is probably with state. But I don't want to do that now. I don't think I'm going to get very far with it. So yeah, I'm just going to leave it at this point. Sorry, that's a bit disappointing. Thanks for watching along. It's been an experience with the Linuxing, and Helix was actually fine. I just need to work out how to get rid of the colors. Kept switching to the wrong window, which is a bit annoying, but we're getting there with it. But yeah, for next week, I'll try and be more prepared. I'll either have more of a think about how to solve it, or I'll pick an easier exercise. It doesn't have to be today's one. But yeah, thanks for watching, and then hopefully see you next time. Goodbye.